Morning, back again. Today we are moving on and going to look at variables. This does build on what we did yesterday. So you'll see in my email I've said do not move on to today's work until you have yesterday's done. So variables. What is a variable? A variable is something that is changed in an experiment or something that is measured in an experiment. So as I keep saying, these variables only apply when we are doing experiments. If you were doing a non-experimental method, so something like a questionnaire or something like a correlation or a case study, you wouldn't have variables because you're not changing and manipulating the setup in any way. So we have looked at let's say Milgram or Ash, and what they did is they took their original experiment and then they did the variations. So you remember that Milgram would have changed the uniform that the teacher was wearing. Ash did things like changed how difficult the task was, but each time they carried out a variation, they kept everything else the same and they changed one thing. So their variable that was changed, that happened, and then they just measured then the results so that they could see what effect that variable and changing that variable had on the results. Okay, so we have two variables. We have an independent variable known as the IV. This is the one which is changed or manipulated in some way. So we call the one that is changed, so for example task difficulty, that would be the independent variable. Legitimacy of the location is what was changed, so that would be the independent variable. The other variable is then called the dependent. So independent and then dependent variable. And this is, can you guess, the variable which is measured. So through every single experiment there will be measurements taken. There will be things that will be recorded, like how many or how quickly, or how something could be something like heart rate. So those results that are taken, that is our dependent variable. That is what is measured. If we were to take an example, so let's take a hypothesis. People who drink more caffeine will remember more items. Okay, let's say, so that's like a hypothesis. People who drink more caffeine will remember more items. So from a hypothesis, you should be able to identify what is the IV and what is the DV, what is being measured and what is being manipulated or changed through different conditions. So you can imagine, if I wanted to carry out an experiment to test this hypothesis, people who drink more caffeine will remember more items. I'm obviously going to have, say, condition 1, condition 2. Condition 1, I might just give somebody 5 milligrams of caffeine. And in condition 2, I might give them 15 milligrams of caffeine. And then I will give them, because remember, everything else stays the same. The only thing that should be changing is the IV. Everything else stays the same. So I would give them exactly the same task. I'd give them a list of items to remember. And then I will record or measure the number of items that they would remember, that each of them remembered. So If I want to identify through my hypothesis what is my IV, what is my DV, sorry, I tend to find that it's always easier to identify the DV first. So what are they measuring here? So what are they going to be recording? You imagine the wee researcher with his recording sheet ready to go. What is he going to be writing down for each participant? And it is going to be the number of items remembered. And then, well, what does that depend on? What is going to affect how many items each participant remembers? What has been changed or manipulated? Well, it is the amount of caffeine. Whether they've been given 5 or 15 or whatever, we don't know, but it's the amount of caffeine. So our IV is the amount of caffeine consumed. And our DV is the number of items remembered. Okay? So our IV, what is being changed from one condition to the other? DV, what is being measured? How are we going to gather our results? What are we recording? Okay, so another type of variable is called an extraneous variable, very big fancy word. So an extraneous variable is anything other than the IV which might have an effect on the results. Because we are studying human behaviour, we can never guarantee that our results are solely due to what we have manipulated or what we have changed or what we're investigating. So if you think of this hypothesis, people who drink more caffeine will remember more items. Well, apart from the amount of caffeine consumed, what else might affect the number of items remembered on that day of that experiment? So that can be anything from the differences in people's memory, just in general. It could be the time of day that they're being tested, because some people perform better in the morning, some people may perform better in the afternoon. So all of those would be identified as extraneous variables. Anything other than our IV or what we've set out to manipulate, which might affect the results. So tends to be, EVs tend to be like situational things. So it could be noise, like distractions. It could be time of the day. It could be also individual differences between participants. Okay, so extraneous variables, we'll try to identify extraneous variables before the experiment sets out, so that if possible we can control them in a way that they won't have such an effect on the DV, our results. That is why something like a lab experiment is going to be the most reliable, because in a lab experiment everything is so controlled, and that allows us to try and control these extraneous variables. If we find that regardless of how much we've tried to control those extraneous variables, that some things did have an effect on the results, that is whenever it becomes a confounding variable. Okay, so you will notice that the only difference in what I've written as a definition for extraneous variable compared to confounding variable is the word which might have an effect, which did affect. So extraneous variables, they are identified at the beginning of the experiment. What other variables might affect my results? So thinking about it beforehand. If I then complete my experiment and I find that there are variables which I know did affect the results, for example, like the weather, or as I said, the time of the day, or individual differences, if I know that they affected my DV, my results, and they weren't anything to do with caffeine, then I can say that they've become a confounding variable. So extraneous variables, confounding variables are exactly the same, except if we're identifying them before the experiment, we call them an extraneous variable. If we're identifying them after the experiment, then they're called confounding variables. Okay, so that is as much as I can teach you on this. You will see on the worksheets that I have emailed to you, there's loads and loads of examples to work through, identifying what's the IV, what's the DV. A couple of questions might ask you to identify extraneous variables, so things that might affect the results but are nothing to do with our IV. And there are some questions towards the end that bring in yesterday's work, asking you to identify if it's a one-tailed or two-tailed hypothesis, as well as identifying the IV and the DV, just to kind of bring everything together. Okay, so that's it for today. Bye.